Good morning. Our project title is Traffic Anticipate for Intelligent Transportation System using Computer Vision. Our project supervisor is Ms. Taglan Desri ma'am, Department of AI&DS. My name is Abana. My teammate are Roshni and Abhinaya. And first of all, problem statement. My project problem is right now in big cities, traffic jam is a daily problem. They waste the people time and cause stress, increase the fuel cost. They will facing so many issues in our traffic, so that right now the most of the traffic will be worked on the instead of fixed timers, so that they will facing the issues like in traffic laws, so that that's why we need a smarter solution. Our project is if you're using AI and computer vision, our project is to detecting vehicles and to estimate the traffic signal automatically. It will reducing our traffic pollution and reduce our congestions. This is our main focus on our projects. And literature reviewer, we are referring 3 or more reference paper. While first paper, it will focusing on the AI and computer vision technique. It will instead of fixed timer, it will automatically focus on traffics and estimate the traffic signal. While the second paper, it will focusing on the surveillance and deep learning system. It will mainly using for surveillance. It will detecting the vehicles and estimate the traffic. And while third paper, it will only prediction for us. It will using the one of the machine learning algorithm, that is ARIMA model. It is auto-regressive integrated moving average model. It will using the machine learning algorithm. It will predicting our paper. And objectives, these are the objective we can gain from our projects. So first we want to predict the traffic in real time. It will using an AI and ML techniques. It will accurately to detecting our then we want to optimize the signal timing. It will adjust the lights based on the vehicle count, which road having a high much vehicle, it will go to priority for the first road, and it will move on to the next road. And then we want to enhance our road safety. It will reducing our accident, especially during emergency hours. It will reduce, and finally it will reduce the travel time and fuel usage, and it will providing insight to the commutators. It will helpful for drivers and city planners and the traffic police also. Finally, it will ensure the scalability. It will adapt it to the various cities, and it will providing the traffic condition to the process. And we have to collect the data set from two main sources. One is from Kaggle and another one is from CCTV videos. We want firstly focus on CCTV images, that is only statistical, so it will not predicting. So we want to move with the one video frame, that statistical image that containing the 70,000 labeled image. It having two features, one is vehicle and non-vehicle, and that features are include like a vehicle type and count and land position. It will move. Our project is mainly focused on domain is a traffic congestion. It want predicted, and that's all. And what are the steps we have to follow in our projects? First, we want to removing null and missing values. It will focusing on the only categorical, not a numerical type, and it will resize the images into uniform, and we want to normalize the pixel value. It will be encoding into categorical, not focus on the numerical, because it will categorical like a vehicle type and land position, like that. Finally, we want to split into two types. One is the training and testing, and training to test the data and testing to tune the data. And what are the tools and library we have used? Pandas for data manipulation, and NumPy for numerical, OpenCV for to processing our images for our video, and TensorFlow to prepare our model.
Now future engineering, we selected features like vehicle type, vehicle count, land positions, movement directions, and traffic density level. Based on this, this impact conjunction prediction accuracy, and which help the traffic signal optimizations, which support short-term and long-term traffic predictions. Our data set was moderator, so we did not apply any dimensional reductions. Now model development, previously we used CNN to capture the image, which used to extract the future, and now we using OpenCV and deep learning method to frame processing and vehicle counting. And currently we used YOLO version 8 because it used to predict the real-time object detections for vehicles, which provide high accuracy and speed detections. CNN effectively captures the spatial patterns of traffic images. This is the architecture of our project. If there is no vehicle, it turn red until there is a vehicle arrived. If the vehicle arrived, the signal turn to green. If the vehicle arrives from various directions, the signal measure the density of the vehicles to show the maximum volume, if the volume is high, there is a green signal. If the volume is low, there is a red signal based on 120 seconds. There is a model implementations. We used tools and platform we used Python programming language in the development environment like Google Colab and VS Code. In the framework of TensorFlow and PyChart, library as OpenCV, Pandas, NumPy, Matplotlib. The challenges we faced as our data set was very limited, so we used a certain vehicles categories. There is a high computational requirement for real-time video processing, handling varying lighting and weather conditions, but we used YOLO because overcome this problem. This is the model implementations of our code. This is the initially we used image processing, so we used statical images. Now we convert into dynamically. First we used statical images. Next, based on the images we separate as train, validation and testing, test split. Now evaluation and refinement, we used accuracy, precision recall, F1 score, mean absolute error and mean square error. Initial result we accurately 85%, F1 score into 0.82, good detection in normal lighting, lower accuracy in low lighting conditions. Now deployment and integrations, we used web applications to show the dashboard for our traffic monitoring. We integrate components as used as YOLO version 8 because it vehicle detections and counting, data processing module to analyze the traffic density, signal control module to adjust the light dynamically, dashboard to display the real-time analysis to traffic operators. This is the example for deployment. This is the dashboard. Based on the density, it will show us green and red. Now conclusions, summary of the progress. To develop a real-time traffic predictions and a signal control system using computer vision and machine learning, we achieved a 90% accuracy in congestion reductions after model tuning. We successfully integrated vehicle detections, counting and the signal adjustment into working protocol. Thank you. This is a reference of data set. This is the paper we referred for our project, and this also. Thank you.
This is our project source code. First, we want to importing our record libraries for our projects. We importing our OpenCV and mainly focus on OpenCV and TensorFlow because our project is it is video database and images. So first we record in NumPy, Pandas and Matplotlib for visualization, NumPy for numerical and Pandas for data manipulation. After that we importing our libraries, we have to train our model. We using the one video. We want to importing one video. That is our projects mainly. This is our video. This is a video we have to get from our Kaggle. It is having two types of length. It will do predicting our vehicles. This is our input video. We will importing our source code. And after that we want to path to image file. We have to convert it. And after showing the output will be it will capturing like a left line and right line. It will capturing using the YOLO algorithm, that is U1 ones. This algorithm capturing the car and bus truck, like that it will capturing. And after that we have to pre-train the model. This is our data set, we have to import it. Otherwise it will showing the what type of vehicle and vehicle to training our images and testing. And we use the one type of data animal. And after that we want to testing and training, we have to number of training images and testing. And after the visualization we will showing. This is the visualization to capturing our vehicle like that. And this is the tuning of our YOLO model. This is our project source code. First we required importing our necessary libraries. We importing our OpenCV and TensorFlow. That is we importing NumPy, Pandas, NumPy for numerical and Pandas for data manipulation and Matplotlib for visualization. This is the important libraries we have to import, and we have using our one input video. This is our input video. This is our input video. We have to collect it from our Kaggle data set. We have collected. After that, we want to importing our video, and this is the importing video. It will showing our what are the things it will capture, like after vehicle counting, it will capturing the like car and bus track. What are the, it will split into two types. One is right line and left line. What are things it capture. After that, it will pre-train the model. What are the type of names it available, like vehicle name it will show. After that, it will train and the testing. We want to split it into two types. One is training and testing. Finally, it will showing the progress data analysis. 90 validation images we have used. We have approximately we have getting 85% for training and 50% for validation. And this is a visualization. It will showing the sample images of our data set. And this is all the algorithm we are using our, this is the overall source code explanation of our project.
This is a model performance evaluations. We post training file path. Next, learning curve analysis. Here the learning curve analysis of class image instant box, and there is a visual box learning curve. This is epoches, classify loss learning curve, and the distribution focal loss learning curve, and the model inference and generalization assessment. This is the image. In the video we predict image like to capture the car, bus, like that. To infer the unseen data also. Based on this input conference. Firstly, we said Google Colab for develop the process. So we give the input to the Google Colab to see the weight, height of the images, video, to show the left count, right count, to give the total count also, simulated vehicle counts, traffic density based on low, high and medium. Thus the traffic signal based on the densities, it show us green, red. These are the dashboard. If the land side there is a 3 vehicle, left side 3 vehicles, right side 10 vehicle, total vehicle 13, but the traffic density is high on high on right side, so there is a green. In the left side there is a 3 vehicles only, so it turn as red. Based on the situation, overall count, output, overall output. Thank you.